Hi students, welcome to Roots Academy. Myself Inayatullah, lecturer of mathematics. Student, in our last video we discussed the concepts of maxima and minima, local maxima and local minima, then absolute maxima and absolute minima. So student, in today's video let us solve the problems of these three topics, and this is the last topic of the chapter called application of derivatives. So let us start the problems of maxima and minima in general. So name of the chapter remains same, it is application of derivatives. In this video we will discuss only the problems of maxima and minima, and this is the last topic of this chapter. Okay students, let us start the problem. The first problem is find the maximum and minimum value of the function f of x is equals to 9x square plus 12x plus 2. Student, in this question he is just asking us to find the maximum and minimum value of this function. And we know that there are two methods to find the maximum and minimum value of any function. The first method is first derivative test. Second method is second derivative test. What is first derivative test? In this particular test, we will differentiate the given function with respect to x, with respect to x. Then we will consider the derivative is 0 because the slope of the tangent is parallel to x-axis. Then we will find the critical values, critical points. It depends on what kind of polynomial function we have or what kind of functions we have. We will get the critical points. That point we will substitute in the given function. Then we will get local maximum and minimum value of the function. In second order derivative test, what we will do? We will first find the derivative of the given function with respect to x. Then we will find the critical values or critical points. That value, once we got, we will differentiate the given function again with respect to x. That is our second order derivative. And whatever the critical points we got, that we will substitute in second order derivative. There we will declare based on the conditions. If the second order derivative is greater than 0, then we will declare the function is minimum. If it is less than 0, we will declare the function is maximum. If it is equals to 0, then it is neither a minimum nor a maximum function. And to find maximum and minimum value, obviously the critical points we will substitute in the given function. Then we will get the minimum and maximum values. These are the two methods we should follow here. So here to this particular problem I will apply first derivative test. Solution. Student, it's my humble request to you that whatever the techniques I will use in this video, you also use the same techniques in your exam. You will get the best marks and you can understand the concepts very easily. You will not get confused, because maximum times I have noticed that students will get confusion. Sir, what is maximum, minimum, absolute minimum, then local maximum, local minimum. There is a lot of confusion in the student for these three topics. So better whatever the techniques I will follow in this video, you also should follow the same techniques in your exam. Then believe me, you will get the best marks. So let us solve this problem. given f of x is equals to 9x square plus 12x plus 2. Okay students, I am following the first derivative test to find maximum and minimum value here. So let me differentiate this. Differentiate f of x with respect to x. So what do we get? F dash of x is equals to f dash of x is equals to 9 is a coefficient as it is. Derivative of x square is 2x plus 12 as it is. Derivative of x is 1 plus derivative of constant is 0. Finally, our f dash of x is equals to 18x plus 12 it is. Okay students, I got the derivative is 18x plus 12. So let us consider that its derivative is 0. If f dash of x is equals to 0, then what we got? This implies 18x plus 12 is equals to 0. That means 18x is equals to minus 12 and x is equals to minus 12 by 18. If you do further simplification, the final value of x is minus 2 by 3. 6 2 times and 6 3 times. So the critical value is minus 2 by 3. Let us substitute this value of x in the given function. Since it is a quadratic equation, we will get only one critical value and we will see what is the points here. At minus 2 by 3, f of x becomes 9 into minus 2 by 3 whole square plus 12 into minus 2 by 3 plus 2. So student, here 3 1 times, 3 4 times, 3 square is 9 and 9 gets cancelled here. So it is 9 into 4 by 9 plus into minus minus 4 into 2 it is plus 2. So this 9 and 9 gets cancelled. 4 minus 8 plus 2 it is. 4 minus 8 is minus 4 plus 2 is minus 2. So this minus 2 is the value of this function. And student, here one more thing, here we got only one value, then this itself is called as maximum and minimum value of the function, of this particular function. This itself we will call it as maximum and minimum value of the function because it has only one value. If there is another value, then I could have easily compare, but here comparison is not possible, so we will declare this itself is maximum and minimum value. So here maximum and minimum value both are same. Student, let us go to the next problem. Next problem is also related to just maximum and minimum. That is, find the maximum and minimum value of the function f of x is equals to sine 2x plus 5. sine 2x plus 5. It is a trigonometric function and constant 5 is added to this. Solution. Given f of x is equals to sine 2x plus 5. Student, if I consider, listen, suppose if this 2x is my theta, since 2x is angle here, and if I consider it is theta, then I know that the maximum and minimum value of sine theta is -1 and +1. So that is -1 less than or equals to sine theta less than or equals to 1. Irrespective of any multiples here, irrespective of any multiples. These are the minimum, this is the minimum value and this is the maximum value for sine. Whatever this multiple is, minimum is always -1, maximum is +1 only in case of sine. But here, student, here 5 is added to this function. Let us follow the function directly as it is. Add 5, then what happened? Add 5 to the inequality, to this condition. Both the side we are adding now. -1 plus 5 less than or equals to sine 2x plus 5 less than or equals to 1 plus 5. So student, -1 plus 5, it is 4 less than or equals to sine 2x plus 5 less than or equal to 5 plus 1 is 6. Now student, as I told here in this case that the minimum value of sine is always -1 and maximum value is +1. But in this particular problem 5 is added, so if I add 5 to this condition, then the minimum value is 4 and the maximum value is 6. Maximum value is 6. And since here he has not specified what is this, then for any real values this is the answer here. So what is our conclusion? Therefore the minimum value is 4 and the maximum value is 6. Okay students, now let us go to the next problem. Find the local maximum or maxima, local maxima and local minima of the function f of x is equals to sin x minus cos x where the value of x is from 0 to 2 pi. Sorry, it is strictly less than. It is strictly less than. Open interval 0 to 2 pi. Also find the local maxima and local minimum value First he is declaring that we should find the local maxima and minima of this function. Means where exactly the function is getting maximum and minimum. Then after that he is asking us to find the minimum as well as maximum value of the function. So student, obviously as we discussed in the last video, wherever we will get a maximum, that itself gives maximum value of the function. Wherever we will get minimum, then at that particular point we will get minimum value of the function. No doubt about it. So let us try to find the maximum and minimum value of this function. Again, it is a trigonometric function. It is 0 to 360. Given f of x is equals to sin x minus cos x. Then what we will get? Okay. Differentiate f of x with respect to x. So f dash of x is equals to, so derivative of sin is cos minus derivative of cos is minus sin, minus into minus plus sin x. Let us find the critical point, and obviously our critical points are between this. So if f dash x is equals to 0, if f dash x is equals to 0, then which implies cos x plus sin x is equals to 0. So sin x is equals to minus cos x. Okay. If I divide cos on both sides, then I will get sin x by cos x is equals to minus cos x by cos x. I can divide sin also, but I preferred cos here. Then cos and cos gets cancelled here. Sin by cos is tan x is equals to minus 1. So tan x is equals to minus 1. Student, in first PC we studied trigonometry in detail. If you have any kind of doubt in this, my videos are available related to this topic. You can refer those videos also. Now here tan x is a negative value and it is 1. Definitely it is either in second quadrant or it is in fourth quadrant. But as the principal value we are taking, then we should follow this in second quadrant. We must follow the second quadrant here, because among the two quadrants, second quadrant is the least for this. So in this case, since he declared that the value of x should be between 0 and 360, this gives x is equals to 3 pi by 4, because we know that tan pi by 4 is 1. Okay, so it is 45 multiples of 45. Why it is multiples of 45? Because it is in second quadrant and it is tan 1. We know that 1 is possible if it is 45 degree. So it is 3 times of 45. Then 3 times of 45. Next is in the second quadrant itself, the another angle which comes between this is in second quadrant is over. The another angle is 7 pi by 4 is also possible here, because 7 pi by 4 comes in the fourth quadrant, but it is less than 2 pi. These two angles which satisfies this condition, 0 to 2 pi. Okay. So let us apply these two critical points to this particular function to know whether it is where it is maximum and where it is minimum. But student, before I go to that, let me apply the second derivative test here. So student, what I mean is, whenever you get a problem called as local maximum and local minimum, better you go for second derivative test. So first derivative test, first differentiation is already exist here. With this we can easily take second derivative. Now differentiate f dash x with respect to x. What do I get? F double dash of x is equals to okay, I'll take this as derivative of cos x is minus sin x plus derivative of sin x is cos x. Now student, we should find the maximum and minimum value of the function. This is a second order derivative. Here, if I apply directly this, f double dash of 3 pi by 4 is equals to minus sin 3 pi by 4 plus cos 3 pi by 4. Second order, cos is negative here at this particular angle, but this gives sin is positive, but already one negative is exist here. So 3 pi by 4 can be written as and I will erase this. Okay. F double dash of 3 pi by 4 is equals to minus sin pi minus pi by 4 second order plus cos pi minus pi by 4. What happened this? Minus 1 sin 180 minus theta is sin theta minus sin pi by 4. Cos 180 minus theta is minus into plus is minus cos pi by 4. Sin pi by 4 is 1 by root 2, so it is minus 1 by root 2 minus cos pi by 4 is also minus 1 by root 2. Cos pi by 4 is 1 by root 2 minus as it is. So the final answer is minus 2 times of 1 by root 2. If we do further simplification to this, it is minus root 2. Minus root 2. So when 3 pi by 4 and the value of x is 3 pi by 4, then we get minus root 2 is the answer. Next, Einstein, in second order derivative test, we know that whenever we will get the second order derivative is less than 0. Whenever we get the second order derivatives less than 0, then the function is maximum. Therefore, the function is maximum at where? At 3 pi by 4. At x is equals to 3 pi by 4. Next, at 7 pi by 4 we will take now. At x is equals to 7 pi by 4, f double dash of 7 pi by 4 is equals to minus sin 7 pi by 4 plus cos 7 pi by 4. So this can be written as f double dash of 7 pi by 4 is equals to minus sin 7 pi by 4 can be written as sin 2 pi minus pi by 4. 8 minus 1, 7 plus cos 2 pi minus pi by 4. 2 pi is 360, sin 360 minus theta and cos 360 minus theta. 360 minus in the sense it is fourth quadrant, so cos gives positive value, sin gives negative value. There is already a negative here, so minus into minus becomes plus. So this gives minus into minus plus sin pi by 4 plus cos pi by 4. Again, sin pi by 4 is 1 by root 2 plus cos pi by 4 is also 1 by root 2. So this becomes 2 times of 1 by root 2. So this becomes root 2. This is root 2. So the value, if the value of x is 7 pi by 4, then the second order derivative is positive. I'll write it here. Is equal to root 2. And this is greater than 0. If the second order derivative is greater than 0, we know that it is minimum function. So the function is minimum at 7 pi by 4. Therefore, the function is minimum at x is equals to 7 pi by 4. Now let us find the minimum and maximum value of the function. So student, same values of x, we should put it in f of x now. So let us this. Now the maximum value of f of x at x is equals to 3 pi by 4 is f of 3 pi by 4 is equals to sin 3 pi by 4 minus cos 3 pi by 4. Sin x minus cos x is the function. So at x I substituted 3 pi by 4. Now we saw that 3 pi by 4 value is, since it is second quadrant, it is positive, 1 by root 2 it is, minus, this is negative in second quadrant, minus into minus it is plus, it is 1 by root 2, answer is root 2 here. We already simplified somewhere here. So student, the maximum value of the function is root 2. exactly where it is, at 3 pi by 4. Is root 2 here. Okay. The minimum value of f of x at x is equals to 7 pi by 4 is f of 7 pi by 4 is equals to, okay, so sin 7 pi by 4 minus cos 7 pi by 4. This is the fourth quadrant, this is also in fourth quadrant. In fourth quadrant sin gives negative, fourth quadrant cos gives positive. So this is minus 1 by root 2 minus as it is, cos is positive, 1 by root 2 minus 2 by root 2. So answer is minus root 2. So student, the minimum value of the function at x is equal to 7 pi by 4 is minus root 2. This is the final answer. Find the local maxima and local minima find the local maxima and local minima of local maximum minimum value, directly will take value of the function f of x is equals to x cube minus 6x square plus 9x plus 15. Understand? Here also same thing, similar problem, but this time it is cubic equation, but procedure remains same because he is asking find the local maxima and local minimum value of the function. And we know that local maxima and local minimum, if you are finding, definitely we should find where it is local maxima and where it is local minimum. Then we can find its values. Okay. So given f of x is equals to x cube minus 6x square plus 9x plus 15. Next, differentiate f of x with respect to x. So what do we get? F dash of x is equals to derivative of x cube is 3x square minus 6, derivative of x square is 2x plus 9 as it is, derivative of x is 1 plus derivative of constant is 0. So finally our f dash of x is equals to 3x square minus 12x plus 9. Let us find the critical points here. If f dash of x is equals to 0, that implies 3x square minus 12x plus 9 is equals to 0. Since it is divisible by 3, so let us divide by 3. What we will get after division? We will get x square minus 4x plus 3 is equals to 0. 3 1 times, 3 4 times, 3 3 times. Yes. Now if you factorize this, then the factors are, okay, I will do the complete factorization. minus 3x minus x plus 3 is equals to 0. Minus 4 if I add and if I multiply same two number I should get plus 3. So minus 3 minus 1 is minus 4. Minus into minus plus 3 ones are 3. Now if I take x common here, x minus 3 minus 1 I will remove. If I remove minus 1, plus x is left out. Plus means 2 minus 1 I already removed here. 1 is left out. So is equals to 0. Now again x minus 3 is common here. If I remove x minus 3, from first term x is left out. From second term minus 1 is left out. So with this I got x minus 3 and x minus 1 are the factors of this quadratic equation. With this I can declare that x minus 3 is equals to 0 and x minus 1 is equals to 0. Then I will get the value of x as 3 and the value of x as 1. These are the two values of x. So let us find the second order derivative test here. Second order. There is a first differentiation here. Differentiate f dash of x with respect to x. What do we get? F double dash of x is equals to 3 is a coefficient as it is. Derivative of x square is 2x minus 12. Derivative of x is 1 plus 0. So final second order derivative is equals to 6x minus 12. So student, I got the second order derivative. Let us substitute these values one by one here. At x is equals to, first I will take 1. F double dash of 1 is equals to 6 into 1 minus 12 is minus 6. Instead I got second order derivatives negative here at x is equals to 1. Means it is less than 0. The moment I said second order derivative is less than 0, then at this particular point it is maximum. Therefore, f of x is local maximum. Sorry, it is local maximum at local maximum or maximum, both are approximately same. There is no much difference here. At x is equals to 1. Now we should find the local maximum value. So let us directly substitute x is equal to 1 in the given function. At x is equals to 1, f of x is f of 1 is equals to 1 cube minus 6 into 1 square plus 9 into 1 plus 15. 1 cube is 1 minus 6 plus 9 plus 15. So student here minus 4 totally plus 19 is the answer here. So student, the local maximum is at 1 and the local maximum value is 19. So at x is equal to 1, we will get the local maximum and the local maximum value is 19. Now let us find at x is equal to 3. So student, I will erase this. At x is equals to 3, f double dash of 3 is equals to 6 into 3 minus 12, 18 minus 12 is plus 6. Since it is a positive value, so it is greater than 0. If second order derivative is greater than 0, then the function is minimum. Therefore, f of x is minimum at x is equals to 3. Then the minimum value at x is equals to 3 is, in f of x I should put x as 3 now. In this function I should put x as 3, and f of 3 is equals to 3 cube minus 9 into 3 square, 6 it is, 6 into 3 square plus 9 into 3 plus 15. F of 3 is equal to 3 cube is 27, 3 square is 9, 9 into 6 it is 54 plus 9 into 3 it is 27 plus 15. So here 27 plus 27 is plus 54, gets cancelled with minus 54. Then f of 3 is equals to 15. So student, the minimum value of the function is at x is equal to 3 and the minimum value is 15. That's it. Find the absolute maximum and absolute minimum value of function f of x is equals to x minus 1 whole square plus 1, where x belongs to minus 3 comma 1. Student, in this problem he is asking absolute maximum and absolute minimum value of this quadratic equation, and he has given the values of x. He has given an interval here, as we have seen in the trigonometric case. He has given the interval from 0 to 360. In this particular problem he has given the interval from minus 3 to 1 it is. So it means obviously our critical points will also from this, between this, and we should check for all these things. Okay, we'll see. Solution. Given f of x is equals to x minus 1 whole square plus 1. So if I differentiate this with respect to x, f dash of x is equals to derivative of x square. Derivative of x square is 2x. Then under the square there is a linear equation, so its derivative is 1 minus 0. First this I considered as x square, so its derivative is 2x. X is x minus 1. Since it is a linear equation, I must differentiate one more time. If I am differentiating one more time, then derivative of x is 1 minus, as it is, derivative of 1 is 0, plus derivative of constant is 0. Finally, our derivative is 2x minus 2. So if dash of x is equals to 0, this implies 2x minus 2 is equals to 0, 2x is equals to 2, x is equals to 2 by 2, x is equals to 1. So I got the value of x is 1 here. Yes, it comes in this interval. Okay. So student, here for these values, let us check so what are the values of x here? Minus 3, minus 2, minus 1, 0 and 1. So these are the direct values we will get in this interval. Minus 3, minus 2, minus 1, 0, 1. Yes, because x is equal to 1. Let us find this by first derivative test. If x is equals to minus 3, then f of minus 3 is equals to minus 3 minus 1 whole square plus 1. Minus 4 whole square is 16 plus 1, it is 17. The next minus 2 minus 1 whole square plus 1, 9 plus 1, minus 2 minus 1 is minus 3 whole square is 9, 9 plus 1 is 10. The next x is equals to minus 1 minus 1 whole square plus 1, minus 2 whole square is 4, 4 plus 1 is 5, and x is equals to 0 means it is 0 minus 1 whole square plus 1. 1 plus 1 it is 2. 0 minus 1 is, sorry, it is minus 1 is 1, 1 square is 1 plus 1 is 2. At the last, at x is equals to 1, so 1 minus 1 whole square plus 1. 1 minus 1 is 0, 0 square is 0 plus 1 is 1. Now for all values of x, if it is a natural number or integer, then the given function is minimum. The given function is minimum. The absolute minimum of the function is at x is equals to 1. And the minimum value of this particular function is 1. What is the absolute maximum of the function? The absolute maximum of the function is minus 3, and the absolute maximum value of the function is 17. 17. So here absolute maximum value is 17 at x is equal to minus 3, and absolute minimum value is 1 at x is equals to 1. Okay friends, now let us take some application based problems of maximum and minimum. So the first problem under this is find the two numbers whose sum is 24 and whose product is as large as possible. So as large as possible in the sense it is maximum, obviously, no doubt about it. So in bracket I will write maximum also. So these are the application based problems of maximum and minimum topic. Before this, whatever we studied, those are the general problems. But for these problems, application based problems, we must use second order derivative test. So what he is telling that there are two numbers. If I add those two numbers, I will get 24 is the answer. And the same two numbers, if I multiply, then I will get the maximum value of the function. So let us see how to solve this. Solution. So first let us consider our two numbers are x and y. Let x and y are two numbers. X and y are two numbers. Okay. Then after this, let us follow the data from the given data. What is given? Data is a given content. What is given here? Sum of these two is 24, he said. So y plus x is equals to 24, or x plus y also 24. Student, with this, I will try my level best to find always y value. We should find the values of y. What is the y value? It is 24 minus x. This is the first part of the question. Now the second part says that if the same two number, if I multiply, I will get the maximum. Now we will take the function. This is our function. Again, my f of x will be x into y. And I know the value of y. What is the value of y? F of x is equals to x into y value is 24 minus x. It means my f of x is a quadratic equation, that is 24x minus x square. So let us find the critical points here. Differentiate f of x with respect to x. So what do we get? F dash of x is equals to 24 as it is, derivative of x is 1 minus x square derivative is 2x. Derivative of x square is 2x. If, okay, finally it is 24 minus 2x. If I consider this is 0, if f dash of x is equals to 0, then what happened to this? This implies 24 minus 2x is equal to 0. 24 is equals to 2x. So x will be 24 by 2, it is 12. My x is 24 divided by 2, that is 12. I have a y value, it is called as 24 minus x. This will called as equation 1. Now, put x is equals to 12 in equation 1 or in y to find the value of y. So what is equation 1? It is y is equals to 24 minus x, and x here is 12. So 24 minus 12 is 12. So it means y is also equals to 12. Let us check. If I add these two things, will I get 24? 12 plus 12. Yes, 12 plus 12 is 24. Okay. First part is over. Now the second part is telling that the product is as large as possible. The second part he says that the product is as large as possible. So already I got first derivative here. Let us differentiate with respect to x to first derivative. Differentiate f dash of x with respect to x. I am trying to find second order derivative of this function. So f double dash of x is equals to derivative of 24 is 0 minus 2 as it is, derivative of x is 1. So my f double dash of x is equals to minus 2. For every values of x, it is minus 2 only, because second order derivative is constant and it is minus 2. Since it is minus 2, it is less than 0. The moment we said second order derivative is less than 0, it is a maximum function. Therefore, f of x is maximum. What is the maximum value of the function? Maximum value is okay, no need to find the maximum value. Definitely maximum value is 12 into 12. 12 into 12, it is 144 is the maximum value. But here our intention is to prove that it is maximum, and we got it here. Okay, so now let us go to the next problem. Find the two positive numbers whose sum is 16 and sum of whose cube is So this is also a bit similar to the previous problem. And this also is asking us to find the two numbers whose sum is 16 this time. First condition. What is the second condition? Sum of whose cube is minimum. Minimum in the sense we should prove second order derivatives greater than 0. Okay. Let us solve this. Let x and y are the two numbers. Okay. After taking x and y are two numbers, let us follow the data. From the data, x plus y is equals to 16. Then obviously our y is 16 minus x. This is my equation 1. Again, the other data is always our f of x. He said sum of whose cube, that means x cube plus y cube. X cube plus y cube. What is x cube plus y cube here? F of x is equals to x cube is x cube plus y is 16 minus x whole cube. So let us differentiate this. Differentiate f of x with respect to x. So this becomes f dash of x is equals to derivative of x cube is 3x square plus 16 minus x whole cube. Its derivative is 3x. First let us consider this is x cube format. And we know the derivative of x cube is 3 into x square. Isn't it? 3 into x square. But this x is not x, it is a linear equation. So we must differentiate this again. If we are differentiating this, just only this part. Its derivative is 16, derivative is 0, minus as it is, derivative of x is 1. So minus into plus is minus. So our f dash of x is 3x square minus 3 into 16 minus x whole square. Now, if I consider this is 0, if f dash of x is equals to 0, this implies 3x square minus 3 into 16 minus x whole square is equals to 0. 3x square is equals to 3 into 16 minus x whole square. This 3 and this 3 gets cancelled. X square is equals to, let us take a minus b whole square formula here. So it is 16 square. 16 square is how much it is? 1, 6 plus 6, 12, 2 carry 1, 36, 3, 256 minus 32x plus x square plus x square. Now this x square and this x square gets cancelled. Now we will get 0 is equals to 256 minus 32x. So 256 is equals to 32x. So finally our x is equals to 256 by 32. student? No. X is equals to 256 by 32. Then our X will be 8. X is equals to 8. Let us check whether do we get y is 8 here. Yes. Put X is equals to 8 in equation 1. Then y is equals to 16 minus 8. So y is equals to 8. Y is also 8. Not necessary that both should be same. It may differ also. But the condition is if you are adding these two, we should get 16 here. So yes, okay, the first part of the problem is over. Now let us focus to second part of the problem. And here is the derivative of the function. Where is this? Okay. After getting the values of x and y, let us try to show the given function is a minimum function. I have first order derivative. Let us find its derivative again. Means its derivative again in the sense I am finding the second order derivative of the given function. Differentiate f dash of x with respect to x. It means I am finding the second order derivative of the given function. F double dash of x is equals to 3 as it is. Derivative of x square is 2x minus 3 is a coefficient. Let us consider it is x square format. Its derivative is 2 into x. Okay. Then under the square it is a linear equation. Let us differentiate one more time. Derivative of 16 is 0 minus derivative of x is 1. Finally, our second order derivative is 6x. Minus into minus is plus 6 into 16 minus x. Let us do the simple multiplication here. F double dash of x is equals to 6x plus 16 into 6. 36, 96 it is minus 6x. Minus 6x plus 6x gets cancelled here. So our f double dash of x is equals to 96. Since it is a positive quantity, so it is greater than 0. The moment we set second order derivative is greater than 0, we can declare that f of x is minimum. Student, this is about today's video. Student, if you have any kind of doubt in this topic, you can put your doubt in comment box. With this problem, student, we completed the problems based on maxima, minima, absolute maxima, absolute minima, local maxima, local minima. And also with this, I would like to tell you that we have completed the first part of our second PUC mathematics. Inshallah, in our next video, we will discuss the next part of the second PUC mathematics textbook, and we will start integration in the next video. And student,